What's up, Algebra 1? Today we are talking about systems of linear inequalities where you graph two different inequality lines and shade and look for the overlap for the solution space. So let's look at some problems. Samuel is remodeling his basement. He has only 2,000 square feet of flooring that he is trying to renovate, and he wants to do carpet. He also wants to do hardwood. And so we have several pieces of information that are important. We know the total that he wants, and we also know the prices of each individual one, and we also know that he's budgeted $10,000. So I'm going to jump into the equation building. First of all, X is the number of square feet he wants for carpet, Y is the number of square foot he wants for hardwood, and no matter how much square foot he has, no matter how much he wants of carpet and hardwood together, when you add those together, that cannot exceed 2,000. And then you have another statement that's all about money. All of the values that have price tags in front of them, those dollar signs, those all go together because $4.50 per square foot of carpet, $8.25 per square foot of hardwood, this cannot exceed $10,000. So now we're going to talk about graphing those ideas along with testing certain ideas. Like B says, what about 400 and 1,200? Well, 400 and 1,200 would not exceed 2,000 square feet. However, the pricing, if you were to do 450 times 400 and 825 times 1,200 and add those together, you exceed 10,000. So no, you have enough square foot for that, but you don't have enough money for that. So the next part is to graph the systems. So over here, I've taken time to subtract X to the other side so that I can build my first inequality. So 2,000 is my starting point, and then if I go down 1 over 1, I'll go all the way down until I hit 2,000 on the x-axis. So the idea is that I could get either 0 square feet of one and 2,000 of the other, or vice versa, and everything in the middle. Well, the other one has a little more work into it. You've got to subtract 4.5x to the other side, and then we need to divide 825 into all the values on the right, and that is where I get this equation here, or this inequality rather. So once I start graphing this one, I'll start at 12, 12. That's this value here. And then that will go all the way down to some other x value, which I wasn't sure of. So what I did was I went ahead and said, okay, what will make the y value 0? On the x-axis, which is what I'm looking for the x value that makes the output 0. So I went ahead and added 6/11 x to the other side, and then I multiplied by the reciprocal to figure out what that x value would be, and that turns out to be 22.2. So that are 2,222.2 repeating. So that means I'm going to connect those 2 points on the axis. Now, what I've done is I've shaded below for both of these, but I don't want to be below, I want to be below both lines. So for example, you really want to see your shading under both lines. I had to change my graph a little bit. So any point that's below both of these lines would be in the solution space, okay? So for example, 10, 10, I could buy 10 square feet and 10 square feet of each one, or I could do 50 square feet and 50 square feet of each one. That would work in the pricing and the amount of square feet total. Now you could not get 2,000 square feet of each one because that would be way too expensive and you don't have near the room for it. So one of the things it asks is, what is the point of intersection? So what I've done is I've gone into the calculator and I've graphed negative x plus 2,000, and then I went ahead and put negative 6 over 11x, but for this y-intercept part, I wanted to put that exact value. I didn't want to round, so I put in exactly 10,000 divided by 825. Now I did mess with the window a little bit. I wanted to go 0 to 2,500 on the x-axis so that I could see that last x-intercept, and then I wanted to exceed 2,000 on the y-axis so that I could see the y-intercepts. So now I get this picture here, and it looks like they cross somewhere in this bottom area. And so I'm going to ask the calculator if it'll tell me their intersection points. So second trace, go down to number 5, or just press 5, and then press enter 3 times, and it'll tell me that that intersection is 1733.3 repeating and 266.6 repeating. So that is this point right here. This point of intersection. I've got to look at it again. I think it's 1733 if I remember correctly. Yeah. .3 repeated, and the other one was 266.6 repeated. So these are where the two ideas meet in terms of having exactly 2,000 square feet and then maximizing the amount of money that you could spend. You could spend $10,000 exactly if you got these values in terms of square foot. So the next section is a little more less context. You don't have a lot of reading to do. There's no problem solving. It's just simply, can you graph the lines? So the first thing I do is I take the first equation and I add x to the other side, and then I want to divide that 3 over, and so I've got my line 1/3 x minus 2. So I started at -2 and I go up 1 over 3 to get the other points. And now I need to think about where I need to shade. It looks like I need to shade less than. So I'm going to shade below that line I just graphed. And so now I'm going to take a moment to graph the other one. Let's add 5x to the other side. Let's divide 3 over, and you end up getting this equation. So I started at 2, and then I went up 5 and over 3. You could even go down 5 and left 3 to get some other points going. But there's my line. But this one wants me to go greater than or equal. And so I'm going to shade all above that line. And we're looking for the region of overlap. And in this corner right here, this wedge, these points share both overlapping regions. So my solution space really lives in this blue area in the bottom left. Always look for where they overlap. Let's try another one that some students struggle with, starting with this one right here. If you're saying x is less than or equal to 3, we have to go find 3 on the x-axis and then draw a solid line moving up. This is not a function. You can't graph these in the graphing calculator. So anytime you see x equals or x less than or x greater than, we need an x or a vertical line going through the x-axis. And then any values less than 3, that means any value left of this line that I have here. So I can just shade this way a little bit. Now remember, the answer comes from the overlapping region. So I need to graph the other one. Let's add x to the other side. 3y less than or equal to x plus 18. And then let's divide the 3 away to get x completely by itself. That gives me 1/3 x plus 6. So starting at 6, 1, 2, 3, 4, 5, 6. We're going to go up 1, right 3 for the slope part. And then I'm going to ask myself, should this be a solid or dashed line? And because this one is also or equal, I will say all the points on the line are in the solution as well. So I want to make it solid. And the last thing is to notice that this is a less than symbol, meaning I should shade down below this line. And so if I shade below the line, that would look like this. Once again, we're looking for the overlapping area that has shading for both lines, and that looks like this area right here. It's left of my vertical line, but it's below my red line. So any points in this space are considered solutions. Moving on, the stretch is a little difficult. It says, is it possible to create a system that has no solution? The answer is yes. If you had x had to be less than or equal to 2, while also be greater than or equal to 3, you would get something like this. You'd get 2 vertical lines, one shading less than -2, one shading greater than 3. Well, there's no overlapping region, so there's no solution. Is it possible to create a system that has only one solution? No. If it only has 2 lines, if they cross, you're going to end up with infinite points, not just this one point. So that's not going to be possible. And then the third one says, is it possible to do it with 3? Well, it actually is possible with 3. So follow me in this example if you can. I have my red line, and I want to shade less. I have my green line, and I want to shade less. So right now I have overlapping region. But when I add the third one, if I was to draw a horizontal line like this blue one, but force it to be greater than, well now what we've done is we've intersected at this one point in the middle, and that is the only point that really has all of the solutions in it. So that is a little bit tricky, and I won't ask anything necessarily on a test like that, but it's good to stretch your mind in that way. Review, determine whether each has one solution, no solution, or infinitely many. Remember, if you have no solution or infinitely many, that means the x values have canceled out somehow, and either the values that are left are different, meaning there's no solution, or the values left are the same, which is 1. So let's look at A only. You're doing B and C. I start by distributing -3 into 1 minus 8x. That's what I have here on the right. And what I notice is that that gives me 24x on both sides. And when I go to subtract 24x, those end up canceling out, and you're left only with the constants, but they don't equal each other, so that means you have no solution. These are like two parallel lines that never ever cross. So there's no point of intersection, there's no solution. Number 2, wanting to do a quick inequality graph here, so I move 3x to the other side. I start at 7 and go down 3 over 1. And now I want you to do the last part, the shading, that is less than. So I want you to shade in the correct region. Ask yourself which side should be the less than side. Would that be region 1 or region 2? Let's write a linear inequality for the graph given. First thing I notice is that it's a dashed line. Dashed line should be either less than or greater than, not or equal. And it does seem that it's shading below the y-intercept or less than the y-intercept, and so that makes me think we should stick to less than. So let's go y less than. Let's figure out what the slope is. Starting at this point here, I see another good point right there maybe. So this is going up 1, 2, 3, 4, 1, 2, 3, 4, 5. This has a 4/5 slope. So I'm going to say it's positive 4/5 x. And then again, that y-intercept value that's so interesting. Instead of, it's going by 5s by every 3 units. So 5 divided by 3, 5 divided by 3, that is a 1.6 repeated value. That can be a little tricky there. So that is plus, we'll just say 5. Let's see, but that's really 2. So that's really 5 divided by 3. That's only, sorry, it's 5 divided by 3. That's one of them. But double that because I'm on the second one. That is tricky. So that is really 3.3 repeated. That can be tricky for sure. All right, so let's go to the last one. Write an equation for a regression line of the data. I don't want to use January, and you can't put those in the calculator. So I'm going to change those to 1, 2, 3, and 4. And so I've gone into my calculator and put in those values under stat edit, list 1 and list 2. Next thing we do is go over to stat, calculate, and we run, number 4. So let's see what our equation is. It looks like I have 84x plus 32. So I want to see how close this is to being linear. So I'm going to study this R value. It says it's 0.9988. That is very strong. Strong positive. This helps me trust that my inequality here is, my equation here is going to predict the future fairly accurately. So it says use the equation to predict the gym's total membership at the end of the year. So if January is 1, I'm going to jump down here to 12 where it would be December. So the last thing you do, plug in 12 to see what you get. So 84 times 12 plus 32. 84 times 12, 1008. Add 32, it looks like you get 1040. So December would have 1,040 members. Thank you so much for watching the video. I hope this was helpful, and we'll catch you next week.